AI for Integrated Mobility, AIM, initiative at the Indian Institute of Science has launched UVH-26, India's largest open source traffic image dataset, along with a set of AI models designed for Indian urban traffic. UVH-26 contains over 26,000 high-resolution images from Bengaluru's Safe City project and 1.8 million annotations across 14 common Indian vehicle types. The initiative was made possible with support from the Bangalore City Police and Bangalore Traffic Police, who enabled access to the base imagery. The project was brought together researchers and also received support from outreach contributions. I'm Dr. Anubha Jain, senior journalist with ETV Bharat, and today we'll discuss about more about this model and its usefulness with Associate Professor Yogesh Simmhan from the Department of Computational and Data Sciences, IISc. Welcome to our channel, sir.
Hi, Anubha. Glad to be joining you.
Yeah. So, sir, first I'd like to know why is UVH-26 along with AI models are important for India specifically, and how is it different from global traffic data sets or other models like COCO or City Escapes? So, can you please tell me more about this?
Sure. So, as you can imagine, right, there's been a lot of use of AI within urban mobility and transit solutions within India as part of various smart city missions and even sort of locally by the different city governments. Unfortunately, the models that are used by the various vendors who deploy these traffic cameras or safe city cameras and these solutions with these cities, they are based out of models that are trained on video recordings from Western countries, right? From traffic from Western countries, which, as you know, is much more regulated, clean lane system and so on, right? Compared to Indian traffic, which is much more complicated, to put it mildly, right? Furthermore, the kinds of vehicles that you have within these Western countries are much more normalized, uniform, and standardized compared to the variety of vehicles that we have within India, right? Take an auto rickshaw, for example, or a small cargo van. These are very distinctive to India and the global South. So when you start using AI models that have been developed based on Western data sets, they perform poorly in terms of accuracy in being able to detect and classify such vehicles. And detection and classification is a key building block for many other AI solutions for urban mobility, such as counting the number of vehicles, the traffic flow, where congestions are being sort of detected, and so on. So we wanted to plug a gap in a key building block in the availability of data sets. The models themselves, the AI models, they are top-notch models, right? But the model is only as useful as the data it's trained on, right? So what UVH-26 has tried to do is plug in a key gap in the availability of training data from an Indian context, so that models that are built on top of this training data are much more accurate for Indian conditions compared to those trained on Western data.
Okay. So how can the UVH-26 dataset can be used for general public, students, startups, or civic groups, not just researchers at large institutions?
Absolutely, that's a great question, right? In fact, when we posted UVH-26 on Hugging Face a month or so back, for almost 2 weeks, it was the top downloaded, top trending image detection dataset in the world, right? Mm-hmm. That shows you that pent-up demand, right? Because a lot of very smart students, startups, and so on in India who want to sort of come up with better models, right? And unfortunately, so far, they've been having to rely on datasets like COCO that you yourself mentioned. It's very popular. There's also UV-Trek dataset from China and so on. So that's all that they have to train based on, right? So if they come up with a new model architecture, the only thing they can train and validate is on these external datasets, right? By making this India-specific dataset available, now that they know that the data they train on is useful in the Indian context, and the validation that they do, the models that they train, itself is going to be beneficial for India, right? So it's building AI for India in India, right? So many hackathons are conducted routinely in India. Many of them, unfortunately, are a bit of a waste of time, right? Because students put in a lot of enthusiasm, energy for 24 hours, 48 hours, and they build things that eventually are not quite useful, right? They may be good recruiting tools for industry to see how well students perform, but the outcome itself is not very valuable, right? By starting to use something like UVH-26 as part of, let's say, hackathons that are conducted, right? You can actually start putting out new models that are truly useful for the Indian context. Yeah. And the hope is that by putting these models along with the data sets, we ourselves have trained top-notch models from around the world using this UVH dataset, which perform much better for Indian context. We have sort of reports to showcase that. And putting this in the public domain for free, other vendors in India, even commercial vendors, right? It's put in a very permissive open source license. Even commercial vendors can start using our trained models or our data sets, right? To improve their own solutions, right? So by putting this for free out there, all solutions in India, mobility solutions, ought to become better, right? With zero cost to the vendors themselves.
Okay, right. So, sir, the model shows up to 31.5% improvement over global baselines. What does that improvement actually mean for someone driving or commuting in Indian cities?
That's a great question again, right? So again, academic researchers like nice numbers. Quantitatively, we need to be able to show quantitatively that we're better, right? And accuracy is one of these metrics, right? So these numbers have to be taken, be interpreted carefully, right? So like many
Right.
things in science, right? Numbers can be made to show anything that you want, right? So what we have done is that we have identified the key vehicle classes that are relevant to India, about 13 of these classes, based on the Indian Road Congress, which is the data sheet, right, a specification for India, right? And we have done a classification based on these vehicle classes that are approved as a standard in India, right? So the accuracies that you will see will depend, or the accuracy improvements you will see will depend on the vehicle class. For example, a sedan, right, will probably be similar in different parts of the world, right? So the accuracy improvement for a sedan, it may not be so much higher, right? Maybe it's going to be better because we can do it in complex scenes and so on, right? But something like an auto rickshaw, right? Or a sort of different type of SUV in India, right? Or a sort of cargo vehicle or a truck or a bus. These are going to be having distinctive properties or features within India. So there the accuracy is going to be much higher, right? So how does this impact, right? So the impact is going to be a multi-step impact. It's not like tomorrow the layperson on the road is going to see an impact. Like many things, it takes a gradual but sustained effort, right? Step one would be to start incorporating some of these models into existing AI-driven traffic solution, right? Bangalore has been very proactive in this regard. The Bangalore Traffic Police, we've been collaborating for them for more than 3 years actively, and they've been extremely supportive, both in terms of sharing data with IISc, as well as sort of trying to give feedback in terms of what will work for them. So step one would be to start incorporating some of these models into existing solutions, so that if let's say the accuracy of an existing AI model, right, that was doing, let's say, traffic signaling, right, or traffic prediction was going to be earlier on, let's say 70%, that'll become, let's say, 85 or so percent, right, for example. Now, what's that going to do? That's going to sort of improve the signaling pattern, right? Maybe in a whole day, it might lead to maybe a 10% or a 5% improvement, but you have to multiply that by the millions of vehicles that are transiting, right? So the way to think about it is not as how as an individual I will benefit, right? Because an individual may not see the difference in, let's say, a 1 or 2 minute reduction in commute, right?
Right.
But if you multiply it by millions of vehicles, the amount of energy reduction that you have, the cumulative amount of productivity that will improve because the traffic is even faster by 2 or 3 minutes, is going to be much more substantial.
That's true. So, what privacy and ethical safeguards were put in place given that the data set comes from CCTV cameras?
Absolutely, and that's a very key concern, right? That
Yeah.
all of us, as citizens of the country, should have, right?
True.
Because these safe city cameras are there in all major cities, right? And we sort of take it for granted. Of course, India is probably in a slightly better place compared to, let's say, London, which probably has a highly dense number of cameras, even more, millions of them, and even in China, for that matter, which has got it pervasively. Though in these cameras, they're in the public domain. So the moment they're in the public domain, right, there is an inherent reduction in the expectation of privacy, right? So that's how the law says, right? That's one part of it, right? But again, we have to hold ourselves to a higher ethical standard, right, than what the law says, right? So in this regard, what you have been very careful to do as part of putting the annotated data in the public domain is to try and mask out all information that comes with the CCTV cameras. You'll have a watermark overlay that says here's a location, here's a timestamp, and so on. All those things have been removed as part of the data set that we put out there, right? We've also masked out, to the extent possible, all license plates that are being displayed in these, right? So the idea is that you don't want just curious people or any malignant elements to go out there and try to do some deconstruction from that. So we've done a reasonable effort. Of course, there are ultra smart people out there. They can sort of try to deconstruct it from anything that you put out there. But I think we've taken reasonable effort to ensure that privacy is not safeguarded. Because one of the challenges is that the more you start blurring out things and sort of masking out things, the accuracy of the model starts going down, right? So it's the fine balance between ensuring the data is useful from an AI accuracy perspective, at the same time does not be too intrusive from a privacy perspective. And we've tried to find the balance.
Okay, got it. So, sir, in practical terms, if I ask, if you like to highlight, how can city government use these models to improve, daily traffic congestions and accidents or signal timing, etc.?
Absolutely. So here's where I think it requires, these things are extremely hard problems and extremely complex problems, right? That's where there needs to be, and typically the way cities function is that they have vendors who provide them solutions, right, for the city, right? As an individual institution, academic institution, we don't have the wherewithal to solve the entire problem, especially if it has to go as part of a larger complex solution. So the way city governments can sort of start using the model, the first thing would be as part of the tendering process, right? They need to sort of require the vendors to have models that are at least as good as the models that we put in the public domain, which they are getting for free, right? So that itself will automatically raise the benchmark, right, for success, right? The second is also have standardized benchmarks for evaluating these AI models used by the vendors. Because currently, and I've been through some of these purchase committees myself in the cities, it ends up being a lot of eyeballing, right? Let's look at a few examples. If it looks fine just from a human perception perspective, you say, okay, I'll accept the solution, right? But it's much more scientific, right? You should have a benchmarking data set for India, right? Or for the city saying that, hey, does your AI model give me the required accuracy on the data set relevant to my city, right? So that you can compare it in a scientific manner across different data sets, right? The moment you start doing this, the vendors will automatically start sort of either building better models, right? Or adopting the free model that we have available as part of UVH, right? That will automatically raise the boat, right? Across the entire ocean, right? That's one way. The other way is also try to look at what are the impacts of AI, because it's one thing to have a nice news report saying that, hey, we have an AI generated, right, sort of mobility system, right? But another thing to actually see scientifically what is the benefit, right? And that's where oftentimes we get taken away by just a nice headline that says 10% improvement, right? Or on the flip side also, which I sort of sympathize with cities, where it says, oh, this is a horrible solution because we still have traffic jams, right? One thing to realize is that no solution is a silver bullet, right? The silver bullet is better policy, better planning, and so on. And these take 5 to 10 years to implement, right, on the ground, right? It takes sustained effort. Some of it might not be popular, right? Asking people to use public transit is not popular, right? But that's what will fix the traffic jams, right? So I think having data-driven evaluation, saying that, hey, if I'm going to evaluate an AI-driven solution, let me look at it over a longer period of time. Let me do a 6-month or a 3-month pilot, right? Let me look at different choke points in the city, right? And let me have sort of benchmarks. Let's say before, this was the benchmark in terms of congestion. Maybe a particular traffic signal took 15 minutes to flow through for a single cycle. Post, and again, doing counts and classification, how much vehicle was flowing through using some of these models. And post this AI implementation, right? Did it improve or not, right? That way, it's a very data-driven approach to policy making and evaluation rather than just a gut instinct kind of thing.
Very well said, sir. So, sir, student volunteers play important role in creating UVH-26. So my next question is, what does this say about the potential of crowdsourcing in solving large public data challenges?
Absolutely, and that's one of the things I would like to highlight as well. The effort put in by over 1,500 student volunteers, and many of them are undergraduate students, and many of them are not from a top tier institution, because unfortunately, just going back to the earlier hackathon example, students are more than happy to sort of do a throwaway hackathon, right? For 24 hours or 48 hours, have a nice prize and sort of be happy about it, right? But that's not impactful. But something like this, which is very tedious, right? Let me be very honest, right? Sitting and sort of labeling vehicles or confirming the labels is extremely tedious. We try to gamify it so that it looks a bit more competitive, a bit more interesting. But at the end of the day, it is a data annotation challenge, right? But the fact that students put in thousands of person hours into making this happen, right? Annotating millions of boundary boxes truly shows that these are students who are motivated. It's not just about the catchy tagline saying that, hey, I built a model that had 10% better accuracy, and actually put in the hard work required to build the training data for these models, right? So really, it's kudos to these students who sort of didn't look down upon this effort and say it's too low for my sort of high standards, right? And that's where we need to sort of embrace, from a student's perspective, educator's perspective, saying that look for impact. I always say that making 10 lines of code in an open source tool that's used by a million people is way more useful than you writing 10,000 lines of code, which no one is going to use, right? This
Yeah.
annotation challenge is a bit like this, and I would like institutions, organizations, even companies and so on to put more such effort into putting high quality curated data sets for India so that we can start building better models, right? And it doesn't have to be people from India who build these models. It could be people from around the world, right? Just like people around the world are using COCO data sets, even though it's not relevant for their local environment. Likewise, people start using UVH data sets or other crowdsourced data sets from India and build models and donate it to the public as a public good,
Yeah.
right? So definitely students should be more enthusiastic and look for the impact, not just for the cool titles or sort of grand prizes that they get out of
Yeah,
that.
right, sir, right. So, sir, can UVH-26 help smaller or less crowded Indian cities that don't have Bangaluru's scale of infrastructure? So, if so, how?
Right. So I think one of the things that's happened, good things that's happened with the Safe Cities project is that most cities and even large townships do have some of these safe city cameras, right? Again, there's a distinction between traffic cameras and the safe city cameras, right? Traffic cameras tend to be much fewer in number. Even in Bangalore, they're just in a few hundreds, not in the thousands. And they're typically focusing on specific lanes, right, of the traffic, right, in major arterial roads. Those are much easier because you don't have the occlusion or the of the traffic flow and so on, right? Those are much easier to build models for, right? Safe city cameras are more for safety, so they have a wider angle, and they're not necessarily positioned. They're positioned for coverage. They're not positioned to track traffic, right?
Right.
Which means the data set is more harder to interpret. That's why the AI models are more complicated compared to, let's say, a traffic camera. But the safety cameras are there in most cities and townships, so most of these urban locales can benefit from this, right? But that being said, I think even if you have a dozen of these safe city cameras in your city, starting to run these models, trying to understand the traffic pattern, right? Because we've been lucky as part of the AIM project to have several transportation faculty like Professor Vijay Kovali, Professor Abdul Pinjari, and sort of Professor Tarun Ramba, who've been involved with this and been leading this effort from day one. And they tell us that, hey, what you need as a transportation engineer is data that's continuously collected over a long period of time so that we can understand the impact of various decisions, right? Because one day, even in a sort of township, they might say, I'll change this to a one-way road, right? Now, what's the impact of that, right? By having, even running these models on the few cameras that you might have in your city and collecting the data and observing the before and after of policy intervention can definitely help the cities, right? So being methodical, scientific, and working closely with transportation engineers, right? Which I've learned, right? As a layperson, we all think that we are experts on traffic, right? Because we are affected by traffic, right? But understanding traffic requires a scientific mindset as well, like any other discipline, right?
Yes.
So having cities work closely with these traffic engineers and using these AI models to understand how the traffic behaves would be a good starting point.
And in end, sir, I'd like to know, looking ahead, what are the next steps? Do you plan to expand this data set to other cities, include pedestrian or road safety indicators, or integrate it into live traffic systems?
Absolutely, and the answer is all of the above, right? So one thing is that we are in the process of trying to put this together as a series of data challenges, maybe twice a year, right? So that we can start putting out such high quality curated data out there in the public domain. This includes both different cities, because again, traffic in Bangalore can be different from, it's a traffic in Pune, traffic in Kanpur, right? Each
Yeah.
city has its own flavor, right? Or each neighborhood in India has a different flavor. That's one. The other is also looking at, let's say, low light conditions like twilight or nights and so on, because the cameras are IR cameras. They are black and white images, right? So there you'll have a different set of challenges, right? And of
Yes.
course, peak traffic in the evenings are often at the night times, right? So that's another one, right? Also seasonality and so on. That's another part. A third is also, we have a separate project going on, right, led by some of our colleagues like Vijay Kovali, who are looking at traffic safety, right? That's about even understanding how can I use such camera feeds, right? Maybe this is a dash cam feed, and you drive through a section. Can I understand how much of road safety is there in that section? Because there are standards for these. There are even Supreme Court orders that require you to maintain a certain level of road safety. India is unfortunately one of the highest fatalities in the world. So can you even do automated benchmarking of how safe certain road sections are, where black spots are, and so on, right? And also start doing sort of what if analysis, right? So what if For example, we had these challenging circumstances at Chinnaswamy Stadium for the IPL, right? So what if I did a certain traffic flow pattern? What if I had Ola or Uber parking in a certain section, right? How would that affect traffic flow within the cities, right? Trying to do these what if analysis using this data set, right? And using higher level models that we train using that would be useful, right? And we are in close contact with the Bangalore city to see how we can incorporate it into their sort of solution, even if it's like a POC, right? So have it running at a standalone system, just to understand how best we can start improving. Because if it works in Bangalore, which has one of the highest traffic sort of jams in India, right, among the top three, at one point it was number one. It's likely to work in other cities as well. So we want Bangalore to be the front runner in this, working closely with the traffic police, and see how these solutions can permeate to the rest of India.
Right, sir. Thank you, Professor Simmhan, for those insights and for shedding light on how open India-centric data can transform the way our cities move and function. Thank you once again for your insightful thoughts. Thanks a lot.
Thanks a lot for the opportunity. Bye bye.